Go ahead and take a look at videos. There we go. Take a look at our next half of the unit. We're talking about quadratic equations, and we're going to look and see how we can understand what a quadratic equation looks like, what it is, how to graph it, and then after that, start looking at the solutions of a quadratic equation, how to solve it via factoring, and how to solve it using the famous quadratic formula. So today we're going to start with kind of just figuring out what is a quadratic formula, what is it that we need to know, what is it we can do to figure that out. So we're going to start off by understanding what is the standard form of a quadratic equation. So, we're looking at this is going to be our let me grab the right pen, ax squared plus bx plus c is equal to 0. So now, one of the things you've got to know on these is that a, b, and c are the numbers of any equation. So that's the numbers that you have in there. X squared, these numbers right here, these variables won't be changed, won't be inputted, won't do anything else. So the only thing we're going to plug in is a, b, and c. So our three numbers, it's got to be in this order. So the a has to be next to x squared, the b has to be next to the x, and the c has to be by itself. So as we build into it, we make any quadratic equation, all the ones we factored last unit, in unit 7b, make a shape called a parabola. Okay? So a parabola is a U-shaped curve. It looks something similar to this. Okay? That's a positive parabola. So from here, we're kind of think our way down here and go, okay, so now you've each got your graphing calculator, and you're going to go in and remember how we graph this. We hit y equals, and we can go ahead and type these in and see, okay, what do we get when we graph x squared plus 2x minus 5. So the calculator is going to do all the math for us. We're going to see what it looks like, and we're going to graph it. So let's see. So we get a graph that looks something like this. We've got a point somewhere down here, and we're looking at a U shape like this. When we plug this one in, we're going to do very similar things as we graph the other one. We're going to graph that same one. This time, though, it's a negative x squared. If you had to guess, what would negative x squared do to a problem? You're right. It's probably going to change the direction which the graph is going to go. So when I graph this one, this time my graph's going to look something more like this. Okay? So the biggest difference is this a term. The b and c, everything else stayed the same. I mean, the number value changed. But my a term, my first number, it determines how my parabola goes, whether it goes up or whether it goes down. So if I have a positive a, like in our first example, like here we've got a positive x, our parabola is going to open up and make a smile. If we have a negative a term, so over here like in this one right here, we are going to open downward, down, and we're going to have our frown. So negative people frown, positive people smile was how I always learned how to kind of keep that in the back of my head. So from here we have this idea, okay, now that we understand what shape it's always going to create, we kind of understand which direction it's going to go. From here we go, okay, well, what can I do with this? Well, there's something, you'll notice that since it's that shape, that U-shaped, a U is a symmetric object. So symmetry is simply just the idea of I split an object, it's equal on either side. Humans love symmetry. We really thrive on the idea of symmetrical things. So in this case, it's going to be a vertical line that splits the parabola into two parts, or indeed congruent parts. Parabola into congruent parts. Okay? So when we have a formula for that, we have a way that works out so we can see it, and it's just based off, it's actually kind of comes from the quadratic formula we talk about, but it's the opposite of b divided by 2a. And we're going to get b and a from the formula. We're going to get b and a from our ax squared plus bx plus c. We're going to get those numbers from right there every time in the formula. So we're going to play with today's, and then we're going to go from here. We're going, okay, now that I have an axis of symmetry, I know on here, my axis of symmetry would be somewhere like right here. My axis of symmetry would be somewhere right here. So we've got something else we can learn about a vertex. So a vertex is where the two sides meet. This is where the two congruent parts meet. And you'll notice that your axis of symmetry your vertex is going to be on that axis of symmetry. So if it's at the lowest part, we're going to call it its minimum. So if you're swinging it on a swing, wherever you're lowest to the ground, that's going to be your parabola. That's going to be your minimum because you're swinging up and down. And then, but if you're throwing a football or throwing a ball, the top where it starts to come back down towards the earth is your maximum. Okay? Now, we can use the axis of symmetry to help us find the vertex. Because they're on the same point, we know what x is, we can figure out what y is from the formula. So let's take a look at what that means. So we know we have to find, the first thing we're always going to find is the axis of symmetry. So we're going to say the opposite of b divided by 2 times a. And I like to kind of sometimes have my numbers written over here. A is 1, b is 2, c is 15. Okay? A, b, and c. So the opposite of 8 is negative 8 divided by 2 times 1. So I get negative 4. So my axis of symmetry, because we're talking a vertical line, it's where it crosses the x-axis at negative 4. So we're going to say x is equal to negative 4. And since I have this, I now have an x value. And because the formula is y equals x squared plus 8x squared plus 15, I can plug in negative 4 into my equation and figure out y. So I'm going to say negative 4 squared plus 8 times negative 4 times, or plus 15. And I'm going to do the math. Negative 4 squared is 16 minus 32 plus 15. That gives me an answer of y is equal to negative 1. And that's going to give me my parabola. That's going to give me my vertex. My x is negative 4. My y is negative 1. So if I quickly sketch that out, create myself a quick coordinate plane, just a rough one. I'm not really worried about it. I'm just kind of basing it on a 10 by 10 in the back of my head. I go to the left 4, down 1, puts it right about here. And then I go back and look at A. A tells me it's a parabola facing up. And I don't have to worry about how wide or how skinny it is. We're just kind of getting the basic sketch, getting an idea of, hey, this is what this should look like. Okay, so if I look at that equation, I'm like, oh, it should look something. It's got one going up, and I can create a vertex and find my line of symmetry from there. Now, let's take a look at an example where it might face down. So again, we're going to come over here at A, B, and C. Oh, my pen disappeared. Let's try that again. A, B, and C. There we go. My A is negative 1 this time. My B is 10. And my C is negative 23. I'll use C later on. Right now, I'm choosing A and B. So the opposite of 10 is negative 10 over 2 times negative 1. So negative 10 divided by negative 2 is 5. So x is equal to 5. So again, I'm going to plug it into the equation. Negative. Now, this is the important part. Put parentheses around everything that you plug in. If you don't do that, you're going to end up getting it wrong. Your calculator was going to read it wrong. So be sure you're doing it exactly like this, because you can actually type this entire section into your calculator and get the right answer. Okay, so 5 squared is 5, 25, negative 25, plus 50, minus 23, gives me positive 2. Y is equal to 2. So I'm going to get 5 comma 2 is my answer. And again, I'm going to quickly sketch that. Okay, so if I sketch that, okay, yada, yada. So over 5 up 2 puts me somewhere around there. This time, though, my line is facing down, so I'm going to work on my parabola going down. Okay. Now the question is, what happens if there's a number bigger than 1 or negative 1 on the equation? Well, let's take a look at number 4. Doesn't really change anything. It just makes A 4, B 8, and C negative 1. There we go. So I'm going to say, okay, my problem, the opposite of B is negative 8 divided by 2 times 4, so I get negative 1. Okay, so I'm plugging it in. 4 times negative 1 squared plus 8 times negative 1 minus 1. So negative 1 squared is 1. 1 plus times 4 is 4. Minus 8 minus 1. So 4 minus 8 is negative 4. Minus 1 is negative 5. So I get negative 1, negative 5 as my vertex. And I can graph that. Okay, so I'm going to go now left 1, down 5, somewhere right over here. Looking back at A is positive. So it's going to go up. Okay. All right. Pause the video and try number 6 for me. All right. So let's see. A is negative 3 this time. B is negative 24. And C is 42. Negative 42. All right. So let's plug this in and work it out. So, all right. So the opposite of A is 24. times 2 times negative 3. So I have 24 divided by negative 6 is negative 4. So x is equal to negative 4. Okay, so there we plug it in. Okay, negative 3 times negative 4 squared minus 24 times negative 4 minus 42. All right, so a negative 16 squared, negative 4 squared is 16. 16 times negative is negative 48. This is going to be a positive 96 minus 42. So negative and negative make 90. Negative 90, positive 96 is positive 6. So we get negative 4, 6 as our vertex. And again, we're going to graph that real fast. Left 4, up 6, this time facing down. Good job. All right, now we're going to look at the special cases as we end our lesson today. We're going to look at numbers that don't necessarily fit the standard form. Okay, it doesn't fit the ax plus bx, ax squared plus bx plus c. So these have different terms. So if we're going to work this out, we got to remember the a has the x squared term, the b is the x term, and the c is just the number term. So we're looking here, I have an a term because there's my x squared is negative 1. My b term, is 4, and this time there's nothing over here, so I have 0. Okay, so I'm going to work my problem through. The opposite of b is negative 4 divided by 2 times negative 1. So I've got negative 4 divided by negative 2 is positive 2. So I'm going to plug in my equation. Negative times 2 squared plus 4 times 2. So negative 4 plus 8 gives me 4 as my y and a 2. And then I can sketch that real fast. 2 to the right, 4 up. Puts me somewhere right around here. It's a negative a, so it's going to come down. Now, the real trick is on questions 8 and 9. 8 and 9, you're missing terms, but you got to be sure you're missing the right terms, a, b, and c. So we have an a, because that's my x squared. It's 1. I have a negative 3, but that's actually my c term. So my b is 0. There's no x term. There's no one that has an x. So I'm going to say it's just nothing. So when I plug it into my formula for axis of symmetry, I'm going to have 0 equals 2 times 1. Well, 0 divided by 2 is still 0. Okay? So then I can still plug that into my formula. 0 squared minus 3 is negative 3. So 0, negative 3 is my vertex. 0 over, down 3. Let's say it's right about here. My slope, my a is positive, so it's going up. Go ahead and pause the video and try number 9 and see how you do. All right, again, so you have a is negative 2 this time, and no b, it's 0, and you have c as 8. So plugging it in, the opposite of a is 0 divided by 2 times negative 2. Still x is equal to 0. And then I plug it in, negative 2 times 0 squared plus 8 is simply 8. So we have 0, 8. If I sketch it, okay, my point is on 0 over 8 up, and it's a negative parabola. All right, if you have any other questions, please reach out, let me know. I'd be happy to help you.